So yeah, so again, look for, I'll let you know tomorrow for sure what it is. I just haven't had a chance to sit down and remap out this unit, but we're going to move the test up. So just so you know. Okay? All right, so today specifically I want to talk about step 2, determining a horizontal asymptote, and step 2 on our note sheet. You want to have all your supplemental note sheet too, by the way, because we're going to add the lastest of the steps to it today. Okay? All right? So when determining the horizontal asymptotes of a rational function, we compare the degree of the numerator to the degree of the denominator. And we have 3, what do we call it? 3 options, right? Okay. What's our first option? Big over small? Okay. If it's big over small, what? That's a none. Okay. What's our next option? Small over big. Y equals 0, you said, Phoenix? Okay. And what's our third option? It's the same. Okay. And that then is that funky one where it's A over B, lead coefficient to the numerator, lead coefficient to the denominator. Okay? That's step 2. Should be on your sheet. Should be good to go. Okay? Today, I want to focus in on this one, this nunded one. Okay? That's the one we're going to focus in on today, is that when we don't have a horizontal asymptote. Okay? Okay? So we're going to look at today then if the degree of the numerator is 1 bigger than the degree of the denominator, we have something called a slant asymptote. Okay? Right? If it's 2 bigger, we have a quadratic asymptote. So we'd actually have a parabola that's an asymptote. Okay? If it's 3 bigger, we'd have a cubic style asymptote, and so on and so forth. Okay? So, but we're only going to focus in this class, we're only going to focus in on 1 degree bigger, because if it's 2 degrees bigger, then it's all crazy. Okay? Okay? So how do we go about finding said slant asymptote? Okay? So in order to find it, we just simply do the division. Okay? So for instance, that huge word thing, this, that little pop-out thing is that good. All right, so there's my function, x squared plus 4 divided by x minus 2. First thing I got to look at is I got to look and see if anything factors out. Anything factor from the top? Do we agree with x minus 2, x minus 2? No, I don't agree with that either. What about x minus 2x plus 2? Nope, I don't agree with that either. So anything factors from the top? Nope, nothing factors from the top. Okay? Anything factor on the bottom? Nope, can't do it. Okay? So if I were to do my step 2, I would say that what is the degree on the top? 2. What's the degree on the bottom? 1. So this would be a big over a small. So that would be none HAs. Right? But this difference right here is 1. And we're bigger by 1, so now we have to do the division. Now we've got two choices for doing the division. Option number 1 is we could literally do the long division if we wanted to. Okay? Sometimes we might have to. That's why we learned long division. Because if this bottom is a quadratic in itself and the top is a cubic, we might have to do a long division. Okay? Right? Our other option that we're probably going to more along go with is we can do our synthetic division, where we can say x minus 2 equals 0, so x equals 2. So I'm going to synthetically divide 2 into 0, 1, and 4. Okay? Drop it like hot. Multiply, add, multiply, add. Okay? So step number 1, well, so I should say part, what's on our note sheet, this is going to be step 6, the one we're missing, right? Okay. Right. Step 6 is we're going to find the slant asymptote. Okay? Right? That's our qualification. The top, the degree in the top is 1 bigger than the bottom for step 6. Okay? So then, how we go about doing it? Oops, because I had it down there. Okay? So the first thing that we do is we do the division. That's what we just did, either long ways or short ways. Okay? Second thing that we're going to do is we are going to drop the remainder. Which over here, that's this last term, or that last number in our synthetic division. We're going to drop that. It doesn't matter. You will get a remainder. If you don't get a remainder, that means you did something wrong in step 0, because that means that it was factorable. Okay? Just so you know. All right? And then the last step is what's left over is going to be y equals mx plus b. So in this case, our slant asymptote is going to be y equals 1x plus 2. And we would graph that line. 2 up from the origin would be the y-intercept. We put a dot there. Then we would go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, on and on. Or down 1 left, 1 down 1 left, 1 down 1 left, 1 on and on. And it would be a dashed line because it is an asymptote. So it is a dashed line. Slant asymptotes are like horizontal asymptotes. We can cross them. We learned that yesterday that we were able to cross a horizontal asymptote. The only one that we can't cross is the vertical asymptote. had it down here too, but we put it up here instead. So that is the last step. So now you should have everything filled out on your supplemental note sheet. Okay? Step 0 is what? Simplify. Find if anything cancels out. Step 1.
On the domain.
Domain and vertical asymptote. Step 2. Horizontal asymptote. Step 3. Y-intercept. Step 4. X-intercept. Step 5. Hole. Step 6. Now slant asymptote. Step 7. Other points. Okay? Okay? So that's those 8 steps. You're going to do every single draft problem. Okay? Now, on a quiz tomorrow, or on the test to be determined on the new date of the test, okay, we might ask you a question like, here's a function, find the x-intercept. Okay? Well, then you would only have to do step number 4. And that you would have to do all the other steps. We might say, identify any holes in this function. You would have to do step 0 and step 5, because those 2 are paired up together. Okay? Okay? So stuff like that. But if you're graphing it, you got to do all those steps. Okay? Okay, let's do it. Put it to work. Here we go. So here's our function. X squared minus 3 all over x minus 2. X squared minus 3 over x minus 2. Okay? Step 0 says that I need to simplify or factor. Right? Okay? What? Why not? Not a perfect square? Yep, not a perfect square, not a perfect cube, can't factor the top. Agree? Okay? Which means in bottom, can't factor, it's already there. Okay? I would agree. So step 0, done. Which means, what about step 5? There's no holes in this one. Okay? All right? Fantastic. So then we can go right into step number 1. Step number 1 says we need to find the domain. What would the domain of this function be? X tan equal 2, which means the vertical asymptote is x equals 2. Okay? So let's put that on our graph. Step number 2. Degree of the top, 2. Degree of the bottom, 1. So in our step number 2, that means what? No horizontal asymptote. But when I write it, I'm going to say none, but I'm going to put a little asterisk by it. Why am I going to put a little asterisk by it? Because it differs by 1, right? So that tells me that I've got step 6 in play. Okay? So I'm making myself remembering later on down the line. Okay? Step number 3 then said y-intercept, right? Okay. What is my y-intercept? 0 comma positive 3/2? Yep, 0 comma positive 3/2. Because it's negative 3 over negative 2, which is positive 3/2. That's 1.5 right there. Step 4 said x-intercepts. What do I do for step 4?
Set the top to equal 0.
Top equals 0. Can I add 3 to both sides? Can I square root both sides? So x is going to be plus n minus 3. Okay. So that's going to be square root of 3, comma 0, and negative square root of 3, comma 0. That's a great question. How would I put that on the graph? What is the decimal approximation of the square root of 3? 1.7-ish? Okay. Smaller than 2, because the square root of 4 is 2. Okay. Bigger than 1, because the square root of 1 is 1. Okay. So 1.7 would be right there. Negative 1.7 would be right there. Step 5 was holes, right? None? And step 6, slant asymptote. All right, so now we've got to do the division, correct? You want to go synthetic or long? Synthetic, okay? So synthetic division would say I would set x minus 2 equal to 0, and that gives me x equals 2. Then I plug that into 1, 0, negative 3. Drop, multiply, add, multiply, add. So I've done the division. Second part of this step,
Ditch the remainder.
ditch the remainder. Third part of this step. Y equals 1x plus 2. Just so happens to be the same as the one that we did before. Putting it on with a dashed line. Step 7, find other points. So remember, I've got to find my zones, my quote zones of the graph are divided up by the dash. That's out. Yep, dash that. Yep. Remember, that line goes on there, dash 2, because it's an asymptote. Okay. Zones of my graph are divided up by vertical asymptotes, right? Do I have enough points on the left side of my vertical asymptote? Do I need any more? I wouldn't think so. Okay. Oops, this one. There it is. So it's going to come up along here, curve on down, and end up along both asymptotes, like that. Now, remember, these are functions. So can anything go up in here? Nothing can go up in there because then it's not a function. Vertical line test would fail. Okay, so nothing can go up there. So now I've got to look over here on this side, and I've got to test some points over on this side. 1, 2, let's go with 3. If I plug 3 into my function, 3 squared is, minus 3 is, 3 minus 2 is 1. So that goes to the point 3, comma 6. 1, 2, 3, 4, 5, and 6. None of them are going to be very nice anymore. Let's go 4. That's going to be 16, 13 over 2. That's 7.5. And let's see, that was 4, 5, 6. Let's go 6. 33 over 4 is like 8.25. Oh, that should have been 6.5. That's why. Did my maths wrong. I went 7.5. It should have been 6.5. That makes it better. So this one goes up there. Huh? Questions, comments, concerns, clarifications? All right. You try that one. Most of you are already done with it. So let's say here, does this step 0, does it factor? Yes, it does. It factors to be x minus 5, x minus 1, all over x minus 2. Even though it factors, did anything cancel out? No. Okay, so we can still continue with what we need to do and how we need to do it. There we go. All right, so step number 1 then says my domain is all real numbers, but x cannot be positive 2, which means my vertical asymptote is x equals 2. Horizontal asymptote is step number 2. Top degree is 2, bottom degree is 1. That is a none, but with an asterisk because it differs by 1. So I'm going to have a slant asymptote. Step number 3 says my y-intercept. If I plug in 0, anything with an x in my original one goes away, so it gives me negative 5 halves there, which is 2.5. My x-intercept, I set the numerator equal to 0. Now I can use the factored part. And I get 2 of them. 5, 0, and 1, 0. 2, 3, 4, and 5. There. Step 5, no holes, nothing factored out. Step 6, gotta do the division to get my slant asymptote. So I'm going to say x minus 2 equals 0, so x equals 2. I plug 2 into 1, negative 6, and 5. That gives me 1, multiply, add, multiply, add. Gets me there. Drop the remainder. Leaves me with y equals 1x minus 4. So that gives me a y-intercept of negative 4, 2, and 4 with a slope of 1. extra points. Do I need any extra points on the left side? Oh yeah, I got 2 of them over there already, right? So it starts, this one's gonna start up here. It's gonna come down and hit those 2 intercepts. And it's gonna continue along. We're good there. Do I need any on the other side?
You need a couple.
One more? Okay. Alright. I would go with 3. So 3 squared is 9. Minus 18 is negative 9. Plus 5 is negative 4. Over 1. Agree? So, updated schedule now. So you will still have a quiz tomorrow. Okay? So you'll still have that quiz tomorrow on December 1st. Then next week, Thursday, you'll have another quiz. And then you'll have the test the following Thursday. So you have Friday, Thursday going on with assessments. Just works out. Next Friday we're going to school. And Friday, and then I don't want to milk it for another day.